I apologise for the length of this video, but I have edited it as much as I can. I've got here a J72 Joam North Eastern Railway. It's a Bachmann model and it's a split chassis. So I've been asked to convert it for DCC. To which I thought, yeah, that's fine, no problem. I've done these before, split chassis, that's not really a problem, just a bit of thinking. Until I got into this, and boy, it is different. Anyway, I've taken it apart, basically, to have a look before, so it's part disassembled, but I shall just run you through this because it's interesting, and I think I'm going to have some fun doing this. There is absolutely no room inside there. As you can see, the split chassis fills the cab, and it is absolutely ram jam full of, if I can get it apart, ram jam full of metal. There is no room inside there. So if I place that onto there, like that, you can see basically it has taken up every part of that. It just is full. So it causes a couple of problems. Where do I put the chip? I need a small chip, the decoder, and what I'm going to need to do is I'm going to need to grind away some of this metal, because what I want to do is I want to put this Zen 8-pin in, but it of course will be hardwired. I'll cut off the 8-pin plug and I will hardwire it. So it should fit either with this cut away or with a bit here cut away. There is just nowhere else for it to go, so it has to be cut. So that's one job that I need to do. And the rest of it I will show you as I take it apart. So like I say, I've already been in there and taken a few bits and pieces out. So there are two screws holding that base on there. It's a very straightforward, very good design. I mean, I like them. They're really good. So you can see the insulators that are in there already, and this is the motor. The motor is actually inside the chassis there. So I shall show you what we get when we take that off. So yeah, they're the contacts for the brushes. So underneath there are two brush springs. And there it is. The two brush springs are there in the, I don't know, you call it the motor keep. And there's the brushes, and that's the commutator for the motor. Now I've seen nothing like this before. It's similar to the motor that that Hornby use, the style, in their tender driven. So it's similar to that. But you then think, well, crikey, that does pose a problem. I have to insulate the pickups from the motor. So how on earth do I do that? Because you can see that that's an isolated bush in there that runs through from this side, that's the part of the pickup for that pole, and the other pickup for the other pole is on this side. No insulation around it at all. So that's it. So we take it apart further, and you see what we end up with. So that's the separator for the middle of the body, or chassis should I say, and then this other, and that's it taken apart. So when I saw this, I thought, oh boy, this is going to be a doozy of a job. So I have two things to do. I have to get the pickup from the tracks to the cables on the decoder, and then I've got to get the cables from the decoder to the motor, and they should not be a short. It needs to all be insulated. So I'm thinking, how the hell do I do that? So looking at this central insulator, it sits in the hole in the inside of the chassis, and the outside there is a screw which fits into this hole there, which screws into the plastic, and it's on both sides, and it sits up against the metal of the chassis, the screw does. So I thought I can utilize that, because if I put the cable around the screw and feed the cable out of this front part here, that's contact for one side, and then exactly the same on the other side, coming through this front of this chassis, that's the contact for the other side. That will take it through to the decoder, which sounds pretty easy really. That is the easy bit, I think. So that's how I'm going to try to get the power to the decoder, the track power to the decoder. I then have to take from the decoder to each side of the poles of the motor. So what I'm thinking there is I drill through there with a 3 or 4 mil drill, and I attach the contact poles. I attach these they're not playing. Oh, there you go. I attach those with a nylon or plastic screw through there, which will insulate that from the body. And also the same with the bottom one. Drill that out and put a nylon screw through with the same, with that as a contact, solder the contacts onto that. That's the thoughts, that's the idea. So that's what I'm going to do, and I shall film it as I do it. So what I've done there is I've made a soldered ring end on that cable that fits nicely over the screw. That will then sit in there, and that will be the contact for the left-hand rail. I'm going to cut with the Dremel a tiny slot there for that cable to go down, because as I say, there's no room in the body shell, so that should take that in. And I'm going to do exactly the same procedure for the other side. That will then give me the two contacts from the tracks to to the decoder. Okay, I've cut a slot with the Dremel on both of those. I've gone down to below the level of the boss in the recess because I don't want it to guillotine the cable off when we put the screw in it. And I've also made sure that I covered the armature and the magnets, because of course you get iron filings, metal filings that could get into the motor and not be very good for the motor. Sit on there like that. That way, that's it. Tighten up on there. Now I'm going to get my meter to test that, but that should be either side, right track, left track, and that's that part sorted out. Next part is we've got to insulate the motor. So we'll just test for continuity. So this is the left rail. That's fine. And this is the right rail. There's no short at all. Other rail. So we've got a contact now, a cable that we can attach to the decoder. So the only problem I've got left then is isolating the motor. I've decided to do the isolation of the contacts for the motor slightly different way. So what I've decided to do is, rather than drill out each side to 3 or 4 mil, I'm going to start off with a 2 mil hole. Well, not a 2 mil hole, slightly less than 2 mil, because I need to tap it, and use a plastic nylon screw. I've already drilled and tapped that. The only problem with that is that the tap that I've used isn't very long, so it hasn't gone through far enough. I'd like it, because it only goes through about halfway with a proper thread. So what I want to do is I want to go the whole way through with the thread, so that I can have a long screw going through. I might put a nut on the back end of it because it's a split chassis, or I might just leave it alone. So the idea then is that I have drilled that out, and I've also decided that the contact can be obviously on the spring holders, and I've popped a spot of solder on that one there, and a spot of solder on that one, so I can attach the wires to it. So this one goes on here like this. If I can keep hold of it, like that, and that nylon cum plastic screw will go into there like that. Like I say, this is short. The screw is shorter than I really want it to be. I'd like it to go all the way through. I mean, that holds that on there pretty well as it is, but I would like it to come all the way through out the other side. So that is that. And then, as I say, I intend to then attach the cables, the wires, to there for the decoder. And as we take that off there, I'm going to do the same to the other side. Here, this is an insulated threaded tube, and it's insulated from the other side, although it would be the contact for the left hand pickup, and because it's set in slightly lower than that, if I put a nylon screw into it like this side, nothing's going to make a short. So I'm going to drill that out and tap that as well, but I'm only going to tap that halfway down because I want to use the original bolt in there to clamp the two sides together. So using that, because I've got a plastic screw in there, there should be no contact. If it doesn't work, I'm also left with the possibility of drilling it out wider and putting a larger screw in and taking it all the way across. The reason I've not gone that way at the moment is because of the size of this brush spring holder. It isn't very big, and if I drilled a 3mm hole in it, it would still have metal, but there wouldn't be very much. It'd work, I think, but it wouldn't be very much. So that's the plan. I've also decided that I'm going to drive this shaft through this cog and take all this out because I don't want swarf getting in there. So I've decided I'm going to drive that out, take it all out, take the magnets out, and then when I've finished I can clean it thoroughly and have no problems with any swarf or rubbish in. And that's the next job, I think, is knocking that out of there. I'm going to take the armature out, and I've got a couple of blocks of scrap wood just to support it straight and even. I've got a small punch, it's a watchmaker's punch, and a little hammer. Again, it's out of a watchmaker's kit. So I will drive that out and we'll see what we get. There we go. That's it. Lovely. 2 magnets and the armature and the 2 magnets, which look a little bit as if they've picked up a bit of swarf and bits and pieces, so giving all that a good clean, we'll be fine. So yeah, it's looking good. I'm just cleaning that up, and I notice there's a little washer there between the bearing and the armature. It is very, very, very slim, but it's obviously it's important that it goes back because we don't want to be wearing the bearing. Crimes, it rhymes. I'm a poet and I don't know it. So yeah, that needs to go on the back of that. So So I need to make sure that I don't forget it's there and that it does go back when I put it all together. Right, okay. I used the bench grinder in my workshop to grind down to this level of the chassis. I held them in my vise with some decent soft jaws. Each side I did separately. You could make a wooden jig to hold it, to get it in a vise so you don't damage anything. And then I cleaned up the edges with a square file and brought it level and clean. I just took a little bit off that corner there, just for the cables to sit through into that gap. So let's see what we've got here. So this is just, I'm doing this bit because I'm waiting for my tap for this these two holes, this longer tap, to get delivered to me. So if we put that in there and we pop those down there like that, I'll tie them up better before I put it all together. I might even cut those off shorter. So that will be like that. And that to there. And this, what have we got? We've got black and red to the track. So I've got those cables that I'm attaching to these screws either side, so they will run that way like that, and the orange and grey will run across round that side to the motor. So that will end up like that. In theory, that's how it will be, but I'm going to have to be a little more creative with the tracks for the cables, I think, because they don't look as though they're going to be happy in that position that they were just sat. So I'm really not sure how I'm going to do that, but we can see how it goes as we go through the video. So yeah, those are going to have to come into a different, so what have we got there? We've got, that's okay. So if I cut, I might have to cut a little bit more out of the metal, but maybe not, because if those go across there like that, I might get the casing on. And those two, hang on, I've got the wrong one, that one and that one, that one and that one. So it's orange and grey to the motor, red to the front, black to the front, and I've got these. What have I got to do with those? Maybe they will just lie down along there. There might be enough space. There just might be enough space. Well, they fit there. I don't know. I'm not sure exactly where they are inside that body, but they certainly, it fits. There you go. One decoder. Well, that looks pretty good actually. I'm quite pleased with that. Right. So it's a matter of adhering that to the body, isn't it? To the chassis. That went in there beautifully. Good. Right. So I'll work on that now, and as I say, I'm waiting now for the tap to tap these two holes all the way through. I don't know, that'll be here in a couple of days, so and then I'll put it all back together. I'm hoping this decoder will run this motor, but like I say, I can always reuse this chip if this doesn't work, but it's a good exercise. So I'm now going to clean that engine casing, I suppose motor casing, I suppose you'd call it, with some white spirits, just to make sure that it's nice and clean and there's nothing going to foul the rotor that's in there. It's a bit mucky, isn't it? So that's just white spirit. I don't like these new cotton buds that are on paper. They just seem to disintegrate and they don't do like the others. There we are, that's looking better. I'll just give it a wipe across the back face. And what I'll do is I will pop a piece of blue tack on the back of that, and I'll fill that full of oil, that little bearing, so it could, over the next day or so, soak up a bit of oil. There we go. Lovely jubbly. Now that's nice and clean. I'll have no problem putting the magnets and the rotor back in there when it's ready to go. Smashing. I might give it a brush out as well with a stiff paintbrush. I am going to put a little bit of blue tack on the back of that to seal the hole. There we go, out it comes. And I'm just going to let that sit and soak. It might not soak any up, but it's not going to do any harm. I know these bearings are bronze. They're made out of a powdered bronze that's compressed, so there is space in there for oil to stay within the bearing. That's mainly what they were designed to do, like that. My father was an auto electrician, a repairman, and he used to repair dynamos and starters and alternators and all sorts. And of course they had these bushes in, these bronze bushes. And he had jars of different sized bushes above his workshop bench, all sat in oil, just sat there soaking oil up. And I mean, some of them had been there for years and years and years, sat in this oil, soaking it up. So whenever he used one, he was quite confident that he had a good oiled bearing that he was putting into a starter or a dynamo. I've put a bit of contact adhesive on these cables just to hold them together. I use contact adhesive, of course, because it's soft, and unlike super glue, it shouldn't cause me a problem if I want to get them apart. But as I say, a little bit of contact adhesive there. The nail polish on there will be doing a good job. I've put a little bit more on just to make sure that there's no shorting. It's soldering time. So I'm going to do a bit of soldering. What I've decided to do on these cables for the pickups for the track is I'm going to run solder all the way along there, and I can then wrap it around the screw, and it should be neat. That's my idea. So just a little bit of soldering. That's on both of those. I'm going to put a bit of solder on the motor connection as well, doing it all at the same time. Flux on it. Nice clean soldering tip. Keep the kit tip clean, and it works wonders. So there we go, that's the soldering. There we go, so that's made it a little bit more substantial than it was just cable. As I say, the idea now would be to pop that in there like that, and then that will go on here for the right side rail. So I want that to loop round there like that. I want that under the screw, and then that will just screw into there. And that is the pickup for the right rail. I'll trim that off, and that should be absolutely fine. The same on this side. There we go. And that's the second pickup. So the next thing would be to solder those on there. Now I'm not going to solder the grey wire to the bottom yet, because I need to drill a hole in that, so it will be easier not having a wire connected to it. So I'm going to take that one off there. And solder it onto there like that. Use the tweezers. obviously not hot enough. I might need to change the tip in my soldering iron, or it's the metal body of the engine that's taking away the heat. It could be that, so I'll try it again. Down there, like that. I'll try it on that because it's not melted it. I'll also try a bit of flux because that does help. Spot of flux on it. There we go. Perfect. That's it. So as I mentioned before, that being the brush spring, the electrical contact for the motor is directly onto there, nylon screw, and I'm hoping it's going to work. I mean, I'm relying on the motor to actually work through the DCC chip, the decoder. It might not, but we'll have to see, won't we? So that will go down there like that. Again, and I'm also assuming that this is the right hand pickup and right hand motor. If it isn't, I can just swap these two around rather than messing about with this end. I suppose I could do the others, but it would be easier just to swap those over. And as I say, I'm waiting now until I get my tap. I'm going to drill that through and tap it out for another one of those. So I'm sort of, that's it there. And I'm hoping that that will fit onto there, which it should do, as I say. It did before when I had them all flailing all over the place. So I see no reason why that won't fit. Yep, that fits. That will be fine. That just got trapped on the side there. So that's important to make sure that I keep it. As I said earlier on, that if I put a bit of contact adhesive down there, it will keep it in place. I might move it across to the other side actually and put contact adhesive on the other side. That then keeps it all attached on one side, so I could take that off if I needed to without disturbing any of the cables. So I might do it that way, just to get it under there like that with a bit of adhesive. I think that would work. Make sure that's not snagged at all. It's coming along. They might even just stick onto that. I have just opened up this hole because my new longer tap came this morning. That's a good length. I can get right the way through there now, which is good. So I've opened up this hole in this brass tube. I put a 1.5mm drill through it, and I've only gone through to approximately up to that mark there, because I don't want to destroy the thread of the original screw. Now you may wonder why I'm not putting the same thread as the original screws in. I cannot find a plastic nylon screw of 1.7mm. I can find them in the thousands or tens of thousands from the actual manufacturers, but I cannot find anybody that's doing just 10 or whatever, so decided that it would be an easier way to go as to tap it out and rethread it, which I can do. So as I say, that I'd already drilled that hole out, but I wasn't able to get my tap all the way through. So now we tap the rest of the hole. Now you notice there's a little red spot on there. That's for when I get to tap this bottom brass bush, because I don't want to go any further than that. So I just put a little dot on of, believe it or not, my favourite nail varnish. There we go. It's through. That's superb. I have that fully in there now. I shortened the screw. It might be a better idea to have a bolt rather than a screw with a hex head on that you can get hold of and wind in, but that's going to be fine for me. So I've done that one all the way through. This one I'm only going to tap through to just over halfway. So I've got the little dot as for depth, and this is in brass. So brass is one of those metals that's self-lubricating, really. Thread cutting. I think it's a quarter back and 3/4, a quarter forward and 3/4 back, isn't it? Supposedly something like that, as I remember. There we go. It's going in nice and easy because, of course, brass is so much softer than the metal that the chassis is made of. I'm hoping that's not spinning in there. It might be. Doesn't. Let me get my better glasses on, because I think it might be spinning that. That'll be a blow if it is. No, it's not. Yes, it is. It's spinning. Oh, bother. Didn't want that to happen, did we? What to do with that now, then? How do I stop it from spinning? Will I be able to drive it out? I might be able to drive it out. If I drive it out, I don't know. It looks as though it's been tapped there, as if to lock that plastic in place. Certainly I haven't done that. and it was done before it was, or it's been done. Yeah, I don't know. I'm going to have to come back with that. What I have done is I've put the brass screw into the other side to tighten up the brass insert, and then I've run the tap through. The danger with that is I was a little bit worried about that the force that I put onto the brass tube with the thread in it might have stripped the thread inside the tube or of the brass screw that goes in there, but it looks as though I've got away with it, and I'm almost to the mark that I marked on the tap. I think that's going to be enough, because when I draw that out of there, as I say, it's about as far as it'll go now. It's not moving the tube, it's only cutting a thread, so go as far as I can go. I'm stopping at that, and we'll see what I've got. That should be okay. Put a little bit of oil on that. I think that's a little bit too long, but I can chop a bit off the end of that, it's not a problem. Seems to go in there quite nicely. Yeah, it's a little bit tight as it gets to there. I just need to cut a small amount off there to get its right length. I think that's ample. That's gone in that far. I think that's good enough. That will hold that in there quite firmly. I'm sure that'll be okay. Ooh, that is tight now. It's tightened it up a lot. Wowzers. I need a better screwdriver than that to get that out of there. Okay, there we are. I've got that screw out of there. That was rather tight. It hasn't damaged it though. It's in good nick. So you need to be aware that if you use that, if you do like I did there without taking that out, driving it out, it will tighten up the screw on the other side. So, but that seems to be fine. I don't really want to be putting that in again and tightening it up, but just clean the thread. That goes in there quite deep. That's good. I have no problems with that. I've just got to cut the screw and take that into account. It's virtually there. I'm just going to take a thin slither off the end of that. If I could find where my knife was, there it is. Just going to shorten that just a little bit. There we go. So, what do we have now? Let's recap. I've got a screw the full depth of the right hand chassis, gone all the way through with a longer tap, and I've gone through halfway through the right hand chassis on the bottom to leave the threaded side on there. I just need to make sure that there's no swarf in there, don't I? There was a little bit, but that's fine now. So that will clamp to that. That will go through there. And that one will go through there. Yep, that clamps up. And that clamps up on there. So that is to hold the brush spring, which holds the brushes on the motor. And I mean, the brush springs aren't very strong, so it's not going to distort that. I'm hoping that it doesn't get hot. If it gets hot, it'll melt and everything will go pear-shaped, but I don't think it will, but we can see. We'll see. I'll take that off there now. That was to keep the oil in the bearing. And I must say that having put oil onto that bearing, I've put 2 or 3 applications and it disappeared. I'm assuming most of it has gone into the actual bearing itself, so it did need some oil, and I think that's turned out quite well. I think that will be fine like that. The other side going on to there like that. Right, well, I can assemble that now. Now I've done all that. Just one last bit of soldering to do before we put it all together, and that is connect the motor connection of the decoder. Bit of flux. There we go. I think we can put it to the bottom like that. Job done. It certainly helps when you have your soldering iron switched on. There we go. So I think those can be fitted. Right, so I need to just clean this up a little bit. I think that's okay. I'm going to need a bit of grease for that bearing. I should have got that soaking as well, shouldn't I? I've not done that. I've popped some grease on there. It should be fine. Yeah, the rest of this, it looks a little bit dirty, but what I will do on the back of this, I'll use a little bit of switch cleaner. just to clean it up a bit. I don't want to be doing too much near the bearing because it will wash out the oil that I've just put in, so I keep it away from there like that and just give it a quick dry off, and that will get any of the dirt and grease that I've put in there that we don't want, and any iron filings or that can go back together now. That's great. Right, the first thing I need to do is to get this cog back on this armature. So, just having a look at that, it looks pretty good. It's not worn too badly, but what I think I'm going to do is I'm just going to clean up those surfaces of the commutator. I've gone over it with some white spirit, but there's a little bit of carbon left on there, and I think if I give it a little bit of a polish, it won't do it any harm at all. Getting it nice and clean. There we go. This is a glass fibre brush. On a starter or a dynamo repair, you have the armature, which is the traditional wound armature, and you would put that into the lathe and spin it and recut the copper to make it nice and smooth and clean for the new brushes to run on. But of course we can't do that with this. I think that will be fine. Just make sure there's no bridging across the 3 segments of the commutator, and that's ready to go in. I seem to have misplaced the washer that should go on the back of there, because I said, didn't I, at the time, remember there's a washer that goes on there. Let's find it. Okay, I've found the washer. It's like a thrust bearing, I suppose, that. I want a little bit of grease on that shaft. I'm going to put a bit of this Molly black grease onto that shaft. So I've got the washer on, and I'm going to put that back in there. And then I will pop that back onto there. Now it goes down as far as the end of the shaft. So hopefully I can just press it on like that. Might need to give it a tap. It doesn't look as though it's wanting to go any further. Almost there. That's it, that looks like it's flush. Yeah, that's fine. So that's the armature backing. And it's the magnets. Right, it is white to the top and brown to the bottom. That sits in there. And that sits in there like that. Magnets in. So we then put the motor top on, or a little bit of grease on that, I think. There we are. Just push the grease out. I'm not getting all over. I'll pop a bit of oil on that later as well. So now then we have the brushes. 2 brushes. I think I might give those a bit of a clean as well. Nicely clean brushes. Looks like there's a few thousand miles left in those. Brush springs next. Very tricky things. Go everywhere. Oh dear me. Spring contact. And we want our nylon screw. That's one in, and I think we've got to lift that onto there, haven't we? Like that. Make sure it's in the right position. That's the motor back together. I'm just going to pop a tiny bit of oil on the top of that bearing. Now I hope that that is going to run. So the next thing we do is we put the chassis back together again with the cogs and everything in. Okay. So again, we put a little bit of moly grease on there, on those shafts, and a little bit of Don't need too much on that because it will disperse on the cog, on the top cog. Teeth, and I've inspected all those as well, and they're all in good condition, so there's no problems there. Give that a good doing, and that goes onto the top of that. Well, I think that's not too bad. All right, let's have a reorganise. So we now build this back up. That's a spacer. We need the small spacers on the bottom. That one. These are plastic, so I say these are plastic, all isolating either side, each side from each other. Like that. I think I'll pop a little bit of grease on that centre, on that, because that's where it runs against, and it looks as though that large cogwheel has been running against there, so I'll pop just a bit onto that. Right, as long as I've not forgotten anything, all being well, that should just go onto there, if I can find the hole, like that. They all come together. That looks good to me. And I need the little screw. Where's it gone? That's the one. At this moment in time, that's the screw that, it's the only thing that's going to hold it together until I get these two screws in here, which will go in very shortly. So I've already prepared this. I've run solder on those, I've cut them off. That will go nicely into there. I've put more nail varnish on it. Oh, I love my nail varnish, me, you know. So I've put my nail varnish on, and I've already worked on those. So that should fit in there. Nice and tight, making contact. Exactly the same with this other side. Again, nice and tight. And I've just got to make sure that that is flush with the side of the chassis, because We don't want it cutting. I have stuck those excess cables that I'd cut short, that's the stay alive, and I've attached them to the top of the decoder. It's the easiest thing to do, I think. Now these two wires will run across there, and hopefully, if I can bring that down just to there, they will sit nice and quietly without being interfered with. By anything within the motor. And there we go. So what we ended up with, you can virtually see no difference to the way this was when it was just DC. That original screw is in there. I've changed the screw on this side for the nylon screw, but again, I think the original screw was a flat blade, and I've changed that for this crosshead. That's it. So all I've got to do now is put the wheels and everything in. So here we go. I have just noticed I've not cleaned up these wheels, these axles. They're a bit grotty, so I'm going to have to clean those up. I'd forgotten all about them. There we are, I've cleaned those up now. They were a bit sticky and grotty. I'll put some fresh grease in there. It just needs a blob on the bottom of each of those bearings. There we go. That's not right. What have I done? Oh, yeah. Silly me. Get it in the right way around. There. That's it. The right way and the wrong way. I've got 50-50 chance. And trust me, I always manage to get the wrong end. Anyway, there we go. Another spot on there just in case we've shifted it out. Good to go. Greasy fingers, don't want to be putting too much rubbish onto the body. That's a bit of a tight squeeze. There we are, there's the yep, that's up nice and tight, and there we go. All we've got to do now is keep the fingers crossed that it actually runs. So we'll go and do that now. Well, here she is. She's running beautifully. Really satisfying that it's worked. I'm more than happy with it. This is one of the engines that I converted to DCC in the previous video. As you can see, it's running fine. It's nice and smooth. And that's the black one that I also converted. Again, it's working great, just like this its friend. Still going around, nice and smooth.